Hi folks, welcome to our demo. My name is Gaben Baruch, Principal Solution Architect in AWS in the Telecom Business Unit, focusing on generative AI and data. Today we are going to talk about AI for Telecom on AWS. So what we're trying to solve today, we're trying to focus on the challenge for CSPs to utilize and infuse generative AI into their applications using out-of-the-box open source large language models. And they find that the main challenge there is that those out-of-the-box large language models, they are not accurate enough, hence they cannot provide the relevant specialization where it comes to solve telecom use cases. The other thing is, where they do want to fine-tune an open source model, they need to make sure it's cost efficient, right? Because fine-tuning on large amounts of data can be challenging in terms of cost. And the last part we want to solve is scalability and deployment. So once the telcos, the CSPs have actually fine-tuned a specialized model, they need to be able to efficiently deploy it in a scalable way. Okay, so let's talk a little bit about the AWS generative AI stack. So we start from the bottom layer, where we have the Amazon SageMaker AI. This is our managed platform for end-to-end, from building, training, and deploying traditional AI/ML models, as well as large language models. And we start there. This is where we fine-tune our large language model based on a data set that I will share with you the details about in a second. And then we are using the GPUs on the infrastructure layer, where we host the large language models. And we also use our own AWS custom silicon. We will show you later on how we compare the results from both chipsets. And then we go to the middle layer, where we have Amazon Bedrock, the Amazon Bedrock platform, where we host large language models and expose them as an API. We are taking this fine-tuned model and we are exporting it using the custom import feature into Amazon Bedrock, and then we can deploy and use it as an inference at scale. So that is the two main layers that we are going to showcase also during the demo. So how we are going to solve the challenge? We're going to start with fine-tuning using the Amazon SageMaker platform. We are going to use it using the AWS AI chips, the custom silicon using AWS Trainium, comparing it also to the GPUs, the NVIDIA GPUs. And then we are going to move to the inferencing part, where we are going to host the fine-tuned model on Amazon Bedrock. Let's talk a little bit about the architecture before we move into the demo. So we have open source models that we can bring from Hugging Face repository, where you have more than hundreds of models that you can bring into Amazon SageMaker. We run the fine-tuning job using GPUs or AWS Trainium, and then we use the Bedrock custom model import feature into Bedrock, where we host the model. This is where we are going to make an evaluation using LLM as a judge. So we use one of the LLMs to compare the base model to the fine-tuned models, and we'll see what type of results we're getting. So let's go to the demo now. So this is the flow as discussed. We are starting from the data preparation. We have a telecom data set. It's basically a promotions telco data, where we have examples of customers, what type of promotion we should offer to them, and what are the approved promotions that we can use. We store it in S3, we do some pre-processing, and then we start the fine-tuning job. We are fine-tuning a large language model, Llama 3.233 billion, and we use Trainium and GPU. And then we host the model, we do the custom importing into Amazon Bedrock. In terms of performance, those are the results that we have got based on the experiment. So you can see the difference between NVIDIA GPUs, the equivalent EC2, compared to the AWS Trainium in terms of reduction time when we are doing it for training. Those are the numbers for the actual training cost. So you see that the cost saving here is quite significant using the AWS custom silicon. So now let's talk a little bit about how we compare the results between the base model to the fine-tuned model. So here you can see we have created 3 different test cases. I'll give you an example. So here is a test case where we have a new customer with a single service. You can see the results. This is the response coming back from the base model. And this is the response coming back from the fine-tuned model that we use the telecom dataset promotions. And you can see that we use a technique which is called LLM as a judge. It's a feature which is part of the Bedrock evaluation feature. And as you can see, we use Claude 3.5 Sonnet, and we have here different dimensions to compare the results coming from the base model as well as the fine-tuned model, like relevance, personalization, and others. All those are part of that evaluation process. And we have taken basically 3 different test cases where you can see the comparison between the base model to the fine-tuned model. So this is the training data set that we used in order to fine-tune the telco promotion data set. As you can see here, we have customer data. So we have 50,000 records of customer data, including an analysis of how the model should respond and what personalized message was actually created. So we take this data set and we use it for fine-tuning the model. And we also have an improved promotions list because we want to make sure that the model is responding only based on that list of approved promotions. So to summarize, we're talking about 59% reduction in training time using AWS Trinium, 65% cost saving with Trinium compared to the equivalent GPU as we discussed. We are also achieving, as you saw in the results, when we used the comparison using LLM as a judge, we're talking about 90% accuracy using the fine-tuned model hosted on Amazon Bedrock. And of course, we use the rich ecosystem of features available on Bedrock, from evaluation, using LLM as a judge, and other capabilities when we bring in the fine-tuned model. Thank you very much.